Okay, let's just dive right into this one. Today, we're actually taking a pretty huge departure from the usual massive reports or sprawling datasets. Instead, our entire source material for this analysis is literally just a single line of text. Yep, it's a web link, just a basic URL that you'd text to a friend or, drop into a group chat without even a second thought. But as we're about to uncover this tiny little string of text, it's an absolute masterclass in modern digital architecture. We're going to deconstruct this single link, piece by piece, to reveal the hidden mechanics of how we actually share information on the internet today. So, by placing this exact 48-character string under a microscope, we immediately see that there is way more to this text than just a simple video destination. I mean, every single letter, symbol, and number in the sequence has been engineered with a highly specific mathematical purpose. When we copy and paste a link, we usually just think we're sharing a funny clip or maybe an interesting tutorial, right? But actually, we're transmitting this super dense package of routing instructions, asset identifiers, and behavioral metadata. To break this all down, we're going to move through 4 quick phases today: the core premise, unpacking the evidence, points of contention, and finally, the final takeaway. All right, let's kick things off with phase 1, the core premise, the destination. According to our source text, the string kicks off with this exact sequence, https://youtube.b/. Now, to the casual observer, sure, this just looks like a completely standard internet address. But structurally, this actually represents the secure protocol and a shortened domain name that was specifically designed for the rapid sharing of video content. Think of it like the digital equivalent of an envelope carrying a highly specific delivery address. It's essentially telling your web browser exactly which global server it needs to communicate with before it does literally anything else. Notice how these first 17 characters establish this secure, trusted pathway before any actual content is even requested. You see that little S at the end of HTTP? That stands for secure. It means the foundational internet standard being used here guarantees that your connection to the destination is fully encrypted. Basically, your device and the platform servers are performing this incredibly rapid cryptographic handshake. It creates a private tunnel for all the data that's about to follow. Pretty cool, right? Which brings us to our second section, unpacking the evidence, the unique identifier. Right after the domain, our source text immediately drops in this precise sequence of mixed case letters and numbers, O2PH 9P JWU4. And yeah, I know, it looks like a total random jumble of characters. But I promise you, in the architecture of a massive global video platform, this is anything but random. Out of the billions upon billions of videos hosted on servers all over the planet, this exact combination points to one and only one specific video file. So here's the crucial takeaway here. These 11 characters, they represent the exact, totally unique digital fingerprint of the specific video being shared. By mixing uppercase letters, lowercase letters, and numbers across just 11 positions, the platform can mathematically generate trillions of distinct combinations. It's an unbelievably efficient numbering system. It basically ensures no two videos will ever have the same ID, which allows the server to pluck your requested content out of an absolute ocean of data in mere milliseconds. All right, moving right along to section 3, points of contention, the tracking parameter. So our source text doesn't actually stop after identifying the video. It concludes with this little string right here, a question mark, followed by C equals, and then another highly specific 16-character string reading, 2duk gd1r yes wib. Now, in the world of web architecture, that question mark is a pretty big deal. It's a fundamental command. It's basically telling the server, hey, the core request is over, but wait, I have some extra data I want to hand over to you. And that extra data is exactly what we call a parameter. And this brilliantly illustrates the massive difference between simply requesting a video and transmitting appended behavioral metadata back to the platform. That SID you see in our source string, that stands for source identifier or share identifier. When someone clicked the share button to generate this link in the first place, the platform dynamically spun up this extra code and glued it right to the end of the URL. It acts as a digital receipt. It quietly logs the context of how, where, or by whom this specific link was generated. When we categorize this string, we can clearly separate the primary video evidence from the secondary tracking evidence. On the one side, you have the core content. On the other, the share attribution. Platforms utilize these trackers to map out their social graphs. It lets them see exactly how content goes viral, which users are influencing others, and what sharing methods are hitting the mark. Really, it's just a neutral, structural reality of the modern internet. It's how these networks continually monitor and optimize their own distribution. Just think about the literal breakdown of this 48-character string for a second. It's honestly fascinating. The secure domain takes up 17 characters. The actual video identifier, the actual content you care about, only takes up 11 characters. But that tracking parameter, that takes up a massive 20 characters. The metadata actually occupies more space in this link than the identifier for the video itself. I mean, that perfectly illustrates the hidden priorities operating just beneath the surface of our everyday digital tools. Which brings us to our final section today. Section 4, the final takeaway, mindful sharing. So, pulling all this together, our explainer reveals a highly sophisticated 3-step architecture embedded right into a completely simple text string. Step 1, secure routing establishes a safe connection. Step 2, asset identification pinpoints the exact media you requested. And Step 3, behavioral tracking quietly logs the origin of the share for their analytics. And this entire process, it's completely invisible to the user. It all happens in the background, seamlessly guiding you to your content while silently exchanging a wealth of data with the host servers. We live in this era where sharing information is as effortless as a single click, right? Yet, the mechanics behind those clicks are incredibly dense. The anatomy of this URL proves that on the internet, you are rarely just doing one thing at a time. Requesting content almost always means providing data in return. So, we're going to leave you with this final thought to consider regarding your own digital footprint. What invisible data are you quietly passing along every single time you copy, paste, and share a seemingly simple link?